Hey guys, welcome to the first video for chapter 11, section 1, which is about sequences. I am fairly certain most of you would have dealt with sequences a little bit in pre-cal, maybe trig, college algebra, something like that before, but we're going to go a little bit more in depth, obviously, since this is calculus. So 11.1, video 1. What is a sequence? A sequence is literally a list of numbers. Anytime you list something, if it's numeric, it can be considered a sequence. There doesn't have to be a pattern, but in this class, we're only dealing with sequences which have a defined pattern. We normally write them, the individual terms, with the letter A and a subscript to indicate which term it is. So you can see in this list we have A1, A2, A3, A4, all the way to AN, and it can keep going even after that. If it goes after N, we say it's an infinite sequence. So it would keep going forever and ever and ever. So how do we talk about sequences? The very first term, A sub 1, is literally called the first term. No surprise there. Second term, third term, fourth term, fifth term. A sub n, we would call the nth term. And like I said earlier, if this is an infinite sequence, it would keep going past n plus 1, n plus 2, n plus 3, and so on. So notice that the way we number the terms of a sequence is with the integers, 1, 2, 3, 4, 5, the positive integers. So you can think about a sequence as a function where the domain is positive integers, n equals 1, 2, 3, 4, 5, just like we've seen with sums in the past with Riemann sums. We have the sum as I goes from 1 to n, and they're assumed to be positive integers. This is working the same way, 1 through n. It's just a counter. We usually write a sub n to identify a sequence rather than a function itself, because normally, or we don't always have the proper function notation. So in order to properly write down a sequence, you can either just write an like you see in this first sentence, or you can put the list of terms inside of braces, like you see here on the first line of the notation. Or if you have a formula for how to determine the individual terms of the sequence, you can put that formula inside of braces by itself, a sub n. And if you want to be technical, you should say n equals 1 to infinity, but that's implied. You don't have to write that. So this version with just the braces over a to the n is the most common way you'll see sequences written. So let's look at a couple of examples, jump right in. Like I said, there's different ways that you can write a sequence. You can put the formula for the sequence inside braces. You can just write down the formula is equal to a to the n, or you can actually list out the numeric values or the first few numeric values of a sequence. So let's look at these examples. In this first one, part A, we have this first version of the notation has braces, and inside the braces we have n over n plus 1. So that is meant to be a definition of how you find the various terms of the sequence. And then they're using this notation of 1 to infinity. But again, you don't have to write that. This second piece is them showing you another way to identify the sequence just by writing an equals n over n plus 1. And then lastly, which is probably the least common, but will be the easiest for you when you're first learning about sequences, is to write out a few terms. If we let n equals 1, we would have 1 over 1 plus 1, which is 1/2. So that's the first term of the sequence. When n equals 2, we have 2 over 2 plus 1, which is 2 over 3. That's the second term of the sequence. The third term of the sequence, we would plug in 3 over 4. The fourth term of the sequence, we would plug in 4, so we would get 4 over 5. So it can be very helpful to list out those terms to get a better idea for yourself of what does this sequence really look like. So what we have on this first line is 3 different ways of identifying the same exact sequence, okay? So in part B, we have the same 3 ways, but the formula is a little bit more complicated, so it took more room to write it. So our first method is showing us the formula itself inside braces, similar to what we had up top. So we have -1 to the n times n plus 1 over 3 to the n. So it seems like we have a lot going on here, and we do. Let's talk about this first piece, -1 to the n. That is the generally accepted way to identify a term switching back and forth between negative and positive. So for example, when n equals 1, this is -1 to the first. So you'll have a negative sign on your first term. When n equals 2, you have -1 squared. That's positive. So your second term will be positive. Third term negative, fourth term positive, and so on. So this is just a way of making the sequence alternate back and forth between negative and positive. The second notation form is showing us up top just the same way, a to the n equals, and then the same formula. So this last piece at the bottom here is an actual listing of the numeric values. So when n equals 1, we have -1 to the first times 1 plus 1. So that's -1 times 2 over 3 to the first. So we have -2 divided by 3, and that's our first term, -2/3. So notice one of the interesting things is that the way of identifying a sequence makes it already seem like a function. You can pick any n value you want and plug it in. When n is 4, we have -1 to the fourth, which would be positive, times 4 plus 1, which is 5, over 3 to the fourth, which is 81. So our fourth term is 5 over 81, and so on. And then we have a couple more examples of sequences that you can look at. The point of showing these two examples is that n does not start at 1. And that is a good point to make. You do not have to start at 1. You can start anywhere you want. But if you're not going to start at 1 in your sequence, you have to say that, because if you don't write anything here, it's implied that it's 1 to infinity. So here we have the square root of n minus 3 is our formula for the terms of our sequence. And then in this last one, we have cosine of n pi over 6. Okay, so you can see the 3 different ways. I would say that writing out the list of values with the function at the end is probably the least common, like I said earlier. But between the first two methods, you're going to see both of them probably the same, to be honest with you. Okay, this ends the first video of sequences 11.1.